So hello and welcome to our ROS 101 course, A Fun Approach, delivered to you by me, Sammer. So let's first begin with what is ROS? ROS is short for Robot Operating System. So the terminology operating system is not quite suitable for ROS because ROS is not really an operating system. Well, it is a development environment, but why is ROS called a robot operating system if it's not an operating system? Well, in fact, ROS is not an operating system that you can install in your computer and let it manage all your computing tasks. It is just like a specialized operating system that is used for robotic application development. So, what we can say is ROS and operating systems have some features in common. They both manage computing tasks. So when it comes to ROS, it is only concerned with your robotic applications or your robot software. So let's just imagine that you have a team of people working for you, and you are like the head of the business or the CEO or whatever. So you need to make the team work on a mission or some job that you have to divide or break down into a series of tasks that these people have to execute. So what you're gonna do is that you are gonna like submit each task to each staff member, and each one of them is gonna work on their task. So first of all, it doesn't make sense that you're gonna like send these tasks in sequence and then you just deliver or submit task number one to staff member number one and wait for them to finish, and then you receive it and then you just submit the second task to the second staff member. It doesn't work like that. People always work in groups and in parallel. So these people are going to work on these tasks in parallel. So that's fact number one. And fact number two is that these people must have some sort of communication between them, because these tasks will always have to be correlated, and there are a lot of data that have to be shared between the staff members. So it only makes sense that these people will sooner or later communicate with each other to achieve their tasks and integrate their efforts into a single job, and this is the target that you want. This is pretty much the case with operating systems and ROS as well, because you have like nodes instead of people. So just say people become nodes, which are probably some pieces of software or codes that have, like single purpose targets maybe, or single purpose application. And at the same time, these nodes have to communicate with each other and send messages and receive messages in order to perform their function, which overall contributes to the integrated function of the entire team of nodes. And this is basically the philosophy of ROS. So, as I like to say, ROS is the power of teamwork. All right. So, the second question we have to ask is how ROS helps us as robotics engineers. Well, ROS supports modular software design, and what I mean by modular software design is, as I said before, we have multiple nodes, each one performing a specific task, and at the same time, these nodes need to communicate with each other. So let's just say that we are a team of developers working on some major project. In this case, each one of us will develop, for example, his own node or his own source code that he's eventually going to contribute to this project. So when you work on this node, you have to be, flexible enough to change stuff in your node without, collapsing the whole project. So our project cannot be written in a single big chunk of code that we all contribute to, because anyone like removing a line or adding a line might destroy the whole functionality of the code. So we have to follow a more modular approach. That means each one of us has like some task or some piece of software that it has to develop, and this piece of software is supposed to, perform a certain function that contributes to the overall function of the project. So in this case, the modular approach, or these nodes, or the development of these nodes, helps us to achieve our tasks so that we can, for example, when we want to edit something in the project, we just have to pick the node that has to do with this specific functionality or the specific feature and edit it without changing anything in the rest of the project or the rest of the nodes. So the second thing is, which is a very powerful feature, that ROS is open source. So you'll find multiple resources online, and you can go through any code that is being developed or that is already developed in order to, copy some parts of code. You can also contribute to other codes. Some people, including me, just upload their codes to some platform like GitHub or something, and they offer their codes for everybody to share. It's pretty much like, the Arduino community. If you're familiar with Arduino, if you're not familiar with Arduino, then let's just say that ROS is more of a community. It's an open source platform. That means it's accessible to everyone, and it's really free. So that's why there's been some huge developments of ROS over the years, and this is why I find it easy to develop your applications using ROS. So ROS also has many valuable plugins that you can use, and that means it has connections to other pieces of software that can enhance its functionality. For example, ROS has, some visualization features that help you like visualize your tasks right in front of your eyes while you're developing your code, like RViz. Also Gazebo, that helps you simulate a whole robotic, platform right in front of your eyes, even before uploading your code or even before the deployment process, so you can like have a premature assurance of properties before you like upload your code or deploy it somewhere or on some robotic platform. So also you can find that ROS recently had plugins that have to do with other pieces of software like MATLAB, and some really famous software tools that have been there for like forever. So ROS is going to help you like, create a very efficient development environment that will help you, make the development process more efficient and faster. So ROS is also a standard platform. That means it has some set of rules and guidelines that we all as ROS developers commit to. So it is easy to exchange codes. It is easy to read codes and evaluate performance. So we have some libraries that we all know how to use, and in short, you can just upload any project and you can just make the project run by reading the documentation and figuring out which dependencies it needs. So what are we going to do exactly in this course? So basically we're going to go through the basics, and let me elaborate on the fact that no one on the planet can fully do everything that has to do with ROS, because ROS is such a huge platform. You can't be a ROS expert who knows it all. You have to go through the basics first, and even when you go through the basics, and even when you work as a ROS developer for years and years, there are still gonna be things that you don't quite know. So what I'm gonna teach you in this course is not really to learn ROS, but how to learn ROS. So whenever there is a new feature that is, for example, added to the ROS community, you'll be able to understand what this new feature is and how to run your code with new plugins and stuff like that. So once you've gone through the basics, you'll be able to understand pretty much everything. And for example, learn everything by yourself. So a student's best teacher is the student himself or herself. So we'll learn how to create software packages. We'll learn how to, for example, work on some robotic platforms, some really famous ones. We'll also learn how to use the basic ROS utilities to make our projects neat and to produce some really nice outputs. So it's gonna be a course that is being taught through implementation. You have to get your hands dirty in order to learn this stuff. We'll also work in several mini projects, and this is the fun part of the course. So these mini projects will be like, it will help you understand the utilities better, and it will also help you engage in an interactive way instead of just passive listening. In the end, we're going to work on some final project. This project has to do with a real engineering situation where you have a mobile robot that has to do some specific functions, and you are asked as a ROS developer to develop some code or some software package to make this robot work and deliver an outcome that can be documented and delivered to your, for example, your team leader, or if you're, for example, the head of a startup, then you can develop some documentation for some facility that you have a contract with. So yeah, it's gonna be basically a real engineering situation that you have to live through. So we have some prerequisites for our course. So of course you have to have a computer, but this computer has to have some features like a dedicated GPU. So what a GPU is, it's like some processing unit that has to do with graphics, and what we need it for is basically gazebo simulations, because gazebo requires some massive computational power that has that requires the presence of a GPU. GPUs have to do with something called parallel computing, so they help you perform a lot of computations real fast. So your computer has to have some GPU integrated into it, and it's really easy to tell whether your computer has some GPU feature or not by just going to the system information, and that's pretty easy. Well, NVIDIA cards are preferred. And recently, NVIDIA has produced some really nice products that are integrated into a lot of laptops. For example, computing laptops like the Legion family of Lenovo has RTX cards, GeForce RTX cards. Also, the older versions like the GTX cards are excellent for these projects. So, yeah, NVIDIA products are quite fine, if you ask me. We'll also have to have a processor that is at least an Intel 5. Personally, I use Intel i7, and probably most of the laptops on the market currently use i7 10th or 11th generation. So I think you already have that, most likely. So you have to have at least 500 megabytes of free disk space. And this is pretty easy because probably you're gonna go through the process of installing Ubuntu, so you'll have a lot of free space to offer. So speaking of Ubuntu, we need to install Ubuntu operating system on your device, and particularly the 20.04 version. And this is a requirement that is it's preferred to have this version because this is the version I'm gonna use throughout the course. So it's better if we have compatible versions. There are earlier versions like 16 and 18, but we're gonna stick to 20.04 since ROS also has versions that have to be compatible with this operating system. And if you don't know what Ubuntu is, well, Ubuntu is like an open source operating system. I know most of most of students and most of the people really rely on Windows operating systems. So Ubuntu is not like most of the people are not quite familiar with Ubuntu. So Ubuntu is a Linux-based distribution of it's like a variant of the Linux operating system, but it's quite efficient and it's extremely user-friendly. You'll find it much easier to deal with than Windows, for example. And the good thing is it's open source, so you don't have to pay up anything to install it. In case you don't have one and you need to install one, I've just attached the instructions for Ubuntu installation. So if you go like through this link, for example, and you open up, you'll have like an entire page dedicated to the installation of Ubuntu. And you find that the steps are really quite easy. You'll also find the required or the recommended system requirements. So everything is going to be easy throughout this page. And well, I'm using Ubuntu myself even currently, so we'll go through Ubuntu throughout the course. It's okay if you don't know anything about Ubuntu. We'll just go through it, and as I said, it's a pretty efficient operating system, and it's extremely user-friendly. So let's dive in. So once you're done with the installation of your Ubuntu software, you'll find something like that. You'll have a couple of icons on the left, and you'll have this background in front of you. So what's the difference between Ubuntu and Windows? Basically, they are quite the same thing in a lot of features. For example, you have like the Windows concept here. You have like buttons you can press or folders that you can open. So it's quite the same thing in some features. But here's what's different. What's different here is that you have something called a terminal. And in fact, terminals are also available in Windows, but terminals are quite a basic feature that we need in our development process here in Linux distributions. So a terminal is something like that. Let's just open a new terminal. By the way, if you need to open a new terminal, you have to press Control, then Alt, then T. That means open a new terminal. So here's a terminal. And in fact, if you are a fan of pretty old movies, you'll find that earlier distributions of operating systems used like really black consoles or black terminals like this one, but this one is, violet, I guess. Anyway, regardless of the color, this means that we are dealing with the operating system in a very low level fashion. It's like some old school stuff. So why do we need that? This is supposed to be pretty old, right? In fact, we sometimes need some low-level functionalities because it lets us deal with the operating system at a pretty low level so that we can access some stuff really easy, and there are some commands that we can, execute faster on a terminal than by using regular Windows. So for example, let us just investigate some functionalities, some basic functionalities of this terminal. One thing you have to know is that when you're directed here, when you open a new terminal, you're automatically placed in your home directory. So when we talk about the equivalent Windows, visualization of this thing, you'll find that you're somewhere here in your home directory here. So your home directory contains some of your basic folders like documents and downloads. It pretty much looks like the desktop directory of your Windows version. So let's just try something like, for example, navigating from one directory to another using a terminal. Or better else, let's just display all the folders that are present in the current directory, and this is done through a command called list, which is written as ls. So once I write ls, I'll just press enter. So this is quite the same thing, actually, because it displayed the same exact folders that we saw when we opened the home directory via the Windows version of, of accessibility, for example. So I accessed this through, some window or some folder icon or some, or some button. But here we access this through the terminal. using a simple command. So you might find it a bit hard to deal with commands, or you might find that you're not quite able to remember all of these commands. That's pretty alright, because this is how it starts. You'll get used to them through practice. So let us try another command. For example, I need to navigate from the home directory, for example, to, to my music, for example. So how do I do that? What I'll do is I'll type another command called change directory. So its abbreviation is cd. I don't type change directory, I just type cd, but cd just means change directory. So I'll say cd and I'll type music, for example. So, alright, so I did something wrong, I guess. Yeah, it's the M is capital. Alright, so let's repeat that. Oh, by the way, an interesting feature here is that the terminal is able to save your recent commands, so I don't have to type the whole command again. What I have to do is to press the upper arrow in my keyboard, and it will display, the recent commands, or the most recent command that I used. If I keep pressing it, it will also display older commands. So that's pretty good if you're not really good with memorizing stuff. So this feature helps you a lot to get all those commands used before. So what I'm gonna type here is cd, for example, music. So now I'm in the music directory because it's displayed here. So what this address means, this little, I think it's called tilde. I can't really remember the Greek name of this, but let's just say it's a small sine wave or something. So this tilde, for example, represents your home directory. It's like a symbol for your home directory, like the bat symbol is for Batman, for example. And then you'll have a slash. This slash means that, it's like the transition between the parent directory and the child directory. So this is my home and this is the parent directory. Then I place a slash before going into the other part of my address, which is the child directory. So yeah, basically I'm here in the music directory. So if I sorry, that's the browser. If I open up my music directory here, I'll find, for example, there's some file here. I'm not interested in it. I'm just saying that I got or accessed this directory. So what if I want to get back to the parent directory? So you can type cd, for example, home, and that's it. For example, that will get you back to the home directory. Or you can just use the change directory to the parent directory command. So let's just assume that you can't remember what your parent directory name was. So let's get back to, for example, the music directory. So I'll change the directory back into music. And here I'm back in music, but I don't remember really what my home symbol or what my home address was like. So I need to go to the parent, but I can't remember what the parent name was. So I might use change directory. Then I exactly just leave 2 dots here on my keyboard and press enter. So this command, what it basically means is get me back to my parent. All right, which is pretty embarrassing to, say get me back to my parent, but it is what it does. Anyway, so we learned how to list your files and folders. For example, in this music directory here, we can also, for example, let's just say I need to make or create a new folder or a new directory. So what I'm going to do is, for example, get back to the music directory, and then I want to create a new folder with my name on it, for example. So there is another command for creating a folder. It's called make directory. So its abbreviation is mk, then dir, which is short for make directory. So let's just say I want to call it, for example, Sam. Alright, so I'm gonna make a new directory on the music directory. So it's just like I'm creating a new child folder or a new child directory. So here it is. So I can't really see it here on the terminal, but it was made, and we can prove it by going through, the music directory here. We'll find that there is a new folder called SAM that has been created indeed. So that's how you'll, for example, manipulate some folders or get through folders or create new folders through your terminal. It's pretty basic and straightforward. So what if I want to delete this new, for example, directory that I've just created? So there is another command called remove directory. So its abbreviation is rm, and then it's -d. Not sure really what this symbol is. I'll just call it minus. So it's -d, and we need to remove the SAM directory, so I'll just type SAM. So let's get back to the visual representation. Here we'll find that the SAM folder disappeared, which means it worked. So we can do this stuff really here. When it comes to folders, it's pretty straightforward to do it here as well in the Windows-like visualization of my operating system. So I'll go just to music, and then I need to create a new folder. So right-click, new folder, and I'll call it SAM. And this is pretty much the same thing. And then I want to delete it, so I'll just look for delete here, which, move to trash. So I got rid of it. So that's basically some, functionalities using the terminal. Of course, this is not all. It's just pretty much basics of the basics, but it really gives you an idea about how the terminal works in a Linux distribution such as Ubuntu. There are a lot of commands that we're gonna run using, the terminal. So what we need to do now is to install ROS, your Ubuntu operating system. So we're gonna go to a really famous page here, which is called the ROS documentation, or the ROS online documentation, or sometimes called the ROS wiki. So we'll get here, and there is a specific page designated for the installation of the ROS distributions. Here you can find that there are 3 ROS distributions available on the website, which is Kinetic, Melodic, and Neotic. Well, each of these distributions has to do with the year of distribution. So Kinetic, I guess, was was launched back in 2016, I guess. Melodic was launched in 2018, and Neotic was launched in 2020. So it's like there's a new version every 2 years. So since we're using Ubuntu 20.04, which is like the 2020 distribution of Ubuntu, it has to be compatible with Neotic. For example, if you have another Ubuntu version like the 18 version, then you have to go and install Melodic instead. And same thing, if you have an Ubuntu 16, you'll have to install the Kinetic version. So since we have Ubuntu 20, we will install the Neotic version. So first of all, you'll find that the installation is really quite easy when you do it through the terminal. This is one of the things that make the terminal really cool, because you can install pretty much everything through some simple terminal commands that you can copy online. Nobody, of course, memorizes these terminal commands because they're quite lengthy. So, for example, you'll go through the steps. I've gone through them before, but I'm going to display to you how you're going to execute these commands. So first of all, you'll have to set up your sources. So there's a command here that you can basically copy. So you can either just, copy it as a whole. Yep. Just copy it, all of it. You can copy through Control-C, or you can just, right-click and Control. And then what you're going to do is basically, you don't have to be in any specific directory. For installation, you don't have to be in a specific directory. I mean, the music directory will do. If you want to get back to home, it's okay. What you're going to do is just paste what you've just copied. But there's a drawback in the terminal that you can't use the Control-C and the Control-Z and other control commands, or the shortcuts here. So you have to like right click and you have to press paste. So after that, you're gonna press enter. I'm not gonna press enter because I've done that before. I'm just displaying what you're gonna do. And what you're gonna do basically is go through these commands one by one. So first of all, you're just gonna copy this command, for example, and then you're gonna set up your keys. So you're gonna, copy that as well. And you're just gonna paste it here anywhere, and then you press enter. So one thing you have to know is that when running a command that starts with sudo, that means you're like, for example, giving yourself an administrator privilege, and that means you have to run things as an administrator, and therefore the system asks for your password. This password is what is the password you set up for Ubuntu, because Ubuntu doesn't open unless you have your password. So Ubuntu has to have a password. Windows can give you the option of having or not having a password, but here Ubuntu, you have to specify a password, and this is why it is, it's pretty frustrating to lose your password. So I recommend if you have a password that you really keep by heart, or a new password, you just have to write it somewhere because you don't want to forget that. So for example, well, I've done that before, so I'm not going to write my password because I already installed that. By the way, if you, for example, written a wrong command or something that got you, for example, if I press enter here, I don't want to run this, but I pressed enter by mistake. So all what I have to do is to cancel this command from the terminal. I can do that through Control-C. So Control-C here in the terminal doesn't mean copy, it means cancel. And this is why the original copy shortcut doesn't work here. So you have to use the right click for everything that has to do with copying and pasting and stuff. So I'm finished with setting up my keys. So what I'm gonna do next is I'm gonna run this command, for example. So I'm gonna, I'm just copying the steps and going through here and then pasting it and then press enter again. All right. So if you're interested in what happens when you just press enter, so I'll just press enter here and I'll enter my password, for example. So for example, this is just update, some sort of an updating command. It just updates your libraries or stuff. So it just, it upgrades your packages or software packages. And then you go through this, this is the installation process itself, and it gives you one of three options. Well, I recommend the desktop full install, and also the website itself recommends it. So, you have some common ground here. So what I'm going to do is just copy this and paste it in my terminal. And as usual, press enter. It will probably ask you for the password and you supply it, and then it goes on. It may ask you some yes or no question in the middle. So if you want to answer yes, then you leave a Y or type Y and then press enter, and that's it. So it's pretty much straightforward. So yeah, I'll just ignore all of these because these represent installations of individual packages, but we already installed the whole thing, so I don't have to go through that. So we install ROS full. So that's all. What I have to go through next is the environment setup. So this is pretty much the command. This is called the sourcing command, and the sourcing command is something we're going to talk about later, but well, let's talk about it now. The sourcing means that you have to let the terminal know that you need this distribution or this software package, or you'll have to do something that needs this source. This is what sourcing means. You're just picking this software package as a source for your work. So what I'm going to do is just copy it and paste it as I did before, and just paste it here and then press enter as usual. This just sources your Neotic or ROS version. Alright, so you need to, source this as well, or echo the source. What does that mean? Well, there is a file, there's a very famous file that is located in your home directory, and it's called bash rc. So the bash rc is like um, the startup code for your terminal. That means when your terminal is opened, it automatically runs this startup code. So let's investigate what this bash rc is. So if you get to your home directory here, your bash rc, you won't find it really because it's hidden, so you have to unfile it. And how to do that is by pressing Control and then H. You'll find that there are a lot of hidden files that you didn't know about. One of these files is called the bash rc. So you open the bash rc here, and you'll find that there's a couple lines here that have to do with your startup operations for your terminal. So when you run the command, this command, which is the equal source bash rc, and then you source the bash rc itself. And by the way, for Ubuntu 20, you have to use bash, the other version, which is ESH. It has nothing to do with you, just focus on the bash part. So when we open this code, the bash rc, you'll find that once you've typed the sourcing command and you just pressed enter, you'll find that this line has been added to the code, which is source opt ROS neutic whatever setup.bash. So this command here lets the terminal know that you're probably gonna use ROS, so it has to be prepared to have ROS as a source. Alright, so you're gonna use some source functionalities of ROS on the terminal, like running, for example, your ROS core, and we'll get to know what a ROS core is later. So this is what a sourcing command looks like. So interesting to know that this looks like a directory. So if it looks like a directory, it looks like you're having some address here. That means that, well, you can get to it through your, for example, I don't know, your Windows, or your directories, or your visualization here, which looks like your Windows visualization. So I need to get to that. So it's in a directory called opt, then ROS, then neutic, then setup.bash. Alright, let's get to that. So I can't find it in my home really. So I'll get to the other locations, and I'll get to my computer. Right, can we find something here called opt? Indeed, there's an opt, and then there is my ROS installation, right? And this is my neutic distribution. And you'll find here, as far as I remember, yeah, neutic, then setup.bash, you'll find here something called setup.bash. And this is, this is like the code responsible for the setup of ROS on your laptop, on your machine, or whatever. So I'll get back to my home. So that means that you can check if the file has been downloaded and installed through this command, or by navigating through this, through these directories here, through the visualized version of your directories. So if I want to hide these files and folders, again, because they look really ugly, I'm just going to have to press Ctrl H again, and voila, they're gone. Alright, they're not deleted, they're just hidden, by the way. So, alright, let's get back here. So this is what a sourcing means. So there are other dependencies that you can download, and they're pretty basic. So what building means is that you have some code that you have written, and this code does not really run right away. You have to build it first, and the building process means it converts your code, which is written, for example, in a language that pretty much resembles English, into a machine language, which is ones and zeros. So there are packages responsible for doing that, and you have to install them as well. So what I'm going to do is, copy these codes copy these commands as usual, and getting back to my terminal and just, pasting them and then pressing enter. But I'm not going to do that because they're already installed here on my laptop. And if I did that, it would probably just tell me that you've already installed them, or none have been upgraded or something like that. This is what happens when you install something that is already there. So, and you have to initialize something called ROS dip. Alright, so it's, yeah, it has to do with dependencies. I don't have to go through the details really, it's just something you need to have. So I'm gonna, paste it and then click enter as usual, but I'm gonna delete it because I already did that before. And then the initialization of the ROS dep, you'll just run this command first and this command second, and then you're done. You're pretty much done with the installation of ROS. So it was basically like having to copy a couple of commands. You don't even have to know what these commands mean, and that's it, right? Your ROS installation is ready. So before that, maybe you've been asking about configure your Ubuntu repos. So, well, I don't go through this step. I don't go through this step because that is supposed to be the default, setup for your Ubuntu. So you don't have to go through it really because you'll find it already available in the way it's supposed to be. So you can check it out as well if you want. So you have to follow the Ubuntu guide for instructions on how to configure Ubuntu repos. But every time I install ROS, I just find out that it already allows restricted universal multiverse. So if you want to check it out, it's okay. If you don't want to do it, it's probably going to be fine too. So that's the installation of ROS. So let's get to the second step, which is installing something called the catkin tools. So in order to get to this page, I'll just, if you want to go and seek it for yourself, you'll just have to say catkin tools on Google, for example, or your favorite browser. So I'm just going to type catkin tools. So I find the first result, which is the catkin tools, and you'll find a specific page here about installing catkin tools. So I'm going to press it, and here I am. So what I'm going to do here is run a couple of commands as I did before, but here there are multiple options for installing catkin tools. What I'm going to do is I'm going to focus on the option which says installing on Ubuntu with apt-get. I prefer not to say the reason because it's gonna waste time, so let's just go with it. I'm just gonna copy the command as I always do, and I'm gonna paste it here with my right click and paste, and that's it. And you're gonna, well, as I said, I have to just type Control-C because I got something that I don't want to do. Alright, then this command as well, this particular command, which is wget. Alright, then when I'm done with these, I'm just going to go through these commands. It's basically these 4 commands. I have to run them sequentially, and my catkin tools will be installed. Well, you don't have to go through any of the rest of the commands or the rest of the page. You just have to go through these 4 commands, and that's it. And as I said, you will sometimes be prompted to provide your password, and you're going to do that and then press enter, or you're going to be asked like a yes or no question to which you have to reply yes through typing Y and then pressing enter, and that's it, right? So that's the second part of our lesson, which is getting introduced to Ubuntu and installing ROS and catkin tools. By the way, the name catkin might seem a little bit weird, but the catkin tools are one of the tools we use to build our project and build our packages and stuff like that. So let's keep it that way for now until we get to use it actually. Alright, just to sum up what we did today in our first lesson, we've just talked about ROS, and we defined ROS, what it is and what it does, and why do we need it. Then we took like a simple test drive for Ubuntu. We just got introduced to how Ubuntu looks like and how to use a terminal for, some simple functions. And then we went through the ROS installation as well as the installation of the catkin tools, which is the pretty weird name, we were introduced to, and we will know how to actually use this stuff in the upcoming lessons. So that's all for today. See you in our next session.